magnetic quantum number. So magnetic quantum number tells that each orbital again split into some sub orbitals. How they are splitting, let we discuss one by one. P orbital splitting into 3 suborbitals and d orbital splitting into 5 suborbitals, f orbital splitting into 7 suborbitals, s orbital is not at all splitting into suborbitals. So what are they? How they will be? Let we discuss. S orbital will be in a spherical shape. It is spherical shape, S orbital. And p orbitals in dumbbell shape. This is along x-axis, along y-axis, along z-axis. Three are mutually perpendicular axis. That's why in which orientation we can take. Example, see px, this is called px orbital, py orbital and pz orbitals. So in between z, and suppose this is x and this may be y axis. This is y, this may be x and this may be z axis. This is x and this may be y and this may be z axis. So like that, three mutually perpendicularly axis we can take. If the orbital is oriented along x-axis px, along y-axis py, along z-axis pz. So three combinedly we can draw like this: px, py and pz, x, y, z. Next, let's see d orbitals. So d orbitals, let's see, it is along x and y axis. That's why in between the x and y axis, dxy, dyz, dzx, dx square minus y square and dz square. These are the d orbitals, 5 d orbitals along x and y axis. That's why x square minus y square. Along z axis, that's why dz square. F orbital shape is unknown till now and not defined yet, and because they are not having stable shapes, that's why F orbital designations only we know. So 7 designations: F x cube, F y cube, F z cube, F y into z square minus x square, F z into x square minus y square, F x into z square minus y square, F x y z. These are the 7 F subshells. Okay, let's discuss about angular momentum quantum number. So angular momentum, sorry, magnetic quantum number. Magnetic quantum number is proposed by Lande, the scientist name Lande, and these are represented by the letter ML or M, and its values are M is equal to minus L2 plus L, minus L2 plus L, and it is used to know the orientation of orbitals, means arrangement of orbitals, how these arrange. For example, about third point we will discuss once again. Suppose L equal to 2 means it is d orbital we know. So M values are minus 2, minus 1, 0, plus 1, plus 2. So L equal to 2 means 2 into 2 plus 1. 2 into 2 4 plus 1 5. 5 values will come. So 5 orbitals will be there for D. So like that, if L equal to 3, so M values are minus 3, minus 2, minus 1, 0, 1, 2, 3. 7 values will be. So 7 orbitals, F y x cube, F y cube. So for this you can keep the name also. Let's represent these uh, angular momentum, sorry, magnetic quantum numbers here. S orbital L equal to its value 0, L value 0, and magnetic quantum number m also 0. So here for all these s orbitals m value 0. And for p value -1, 0, +1, because for p L value 1, that's why L equal to 1, that's why -1, 0, +1, -1, 0, +1, px, py, pz, like that, -1, 0, +1. Whereas d orbitals like this, -2, -1, 0, +1, +2, -2, -1, 0, +1, +2. This also f orbitals -3, -2, -1, 0, +1, +2, +3. So like that we can represent the magnetic quantum number for the electrons. 3. Next one, spin quantum number. Spin quantum number tells that the direction of spinning of electron inside the orbital. So spin quantum number is proposed by the scientist Uhlenbeck and Goudsmit. Uhlenbeck and Goudsmit, and it is represented by the letter ms. Its values are ms equal to plus or minus 1 by 2. It is used to know the direction of spinning of electron. Direction of spinning of electrons means in each and every orbital 2 electrons will be. If electron rotate in, so let's see, after 4 quantum numbers we can find how many electrons are there in a particular orbit and how many orbitals are there in a particular orbit. Let we calculate. Suppose we are taking third shell, n equal to third shell. In n equal to 3, s orbital is there, p orbital, d orbital, 3s, 3p, 3d. 3s can accommodate, this is only one subshell inside it. In these 3 orbitals are there. In these 5 suborbitals are there. 1 suborbital, 3 suborbitals, 5 suborbitals. And this 1 suborbital, in one only 2 electrons, and in 3 suborbitals 6 electrons, in 5 suborbitals 10 electrons will be. So in third shell total how many orbitals are there? 9. In third shell how many electrons are there? 18. So in third shell number of electrons are n square, that means 3 square. Number of orbitals, 9 orbitals, and electrons are 18, 2n square. So in nth orbit how many electrons are accommodated? That is 2n square electrons. In the nth orbit n square orbitals can be there. N square orbitals will be there, and n square 2n square electrons will be there.